Hello everyone. In today's video, we are going to see variability or spread of data in the chapter representation of data for year 13 and IB students. Let's get started. Variability or spread of data. Consider these three sets of numbers, each with a mean 7. Let's consider that first example 7, 7, 7, 7, 7. Second is 4, 6, 6.5, 7.2, 11.3. Third is minus 193, minus 46, 28, 69 and 177. Although the means are the same, the spread of each set is different. There is no variability in set A because all the values are same here. But the numbers in the set C are much more spread out than those in set B. In this set, the spread is less because the lowest value is 4 and the highest value is 11.3. The difference between these two values is less. But in the third data, the lowest value is minus 193 and the highest value is 177. In this case, the spread is more. There are various ways of measuring the variability or spread of a distribution. Two of these, the range and the standard deviation. To measure the spread of data, we are using two ways. First is standard deviation and another one is range. What is range? Let's understand this first. The range is based entirely on the extreme values of the distribution and gives a quick snapshot of the overall spread of the data. Range will be given by highest value minus of the lowest value. In the sets of numbers above, the set A has the range of 7 minus 7, 0. The set B has a range of 11.3 minus 4 is equal to 7.3. The set C has a range of 177 minus of minus 193. Minus will become positive. And if you add it, your answer will be equal to 370. This is the range of all the three sets we have. Now let's understand standard deviation. Standard deviation is a very useful measure of spread. It gives a measure of the spread of the data in relation to the mean x bar of the distribution. It is calculated using all the values in the distribution. For each value of x, calculate how far it is from the mean. What is our mean? Our mean is x bar. By calculating x minus x bar, we are calculating how far is the distribution from the mean. This is the deviation from the mean. Now square the deviation to give you x minus x bar the whole square. Next, find out the sum of these squares written as sigma of x minus x bar the whole square. You need to add all the values of x minus x bar the whole square. Then divide by n the number of values to give you the variance as sigma x minus x bar the whole square divided by n. Finally, take the positive square root of the given function to get the standard deviation. Standard deviation will be written as root of this value, sigma of x minus x bar the whole square over n. Standard deviation, which is this one, will be written as root of sigma x square over n minus of x bar square. These both the values are same. We will see the proof of this at the later stage right now. Variance. The variance is the square of the standard deviation, where variance will be given by, if you have to do the square of this one, you will get sigma of x minus x bar the whole square over n. This is the value for the variance. Same way, it will be written as sigma x square over n minus of x bar square. Variance is equal to standard deviation square. Standard deviation is equal to root of variance. Let's see the proof of the standard deviation that these two values are same. We will derive it right now. Variance will be given by sigma of x minus x bar the whole square over n. Let's apply the formula here as a minus b the whole square. Expand it. This will be written as sigma of x square minus of 2x x bar plus x bar the whole square over n. This will be written as sigma of x square minus of sigma of 2x x bar plus sigma of x bar the whole square over n. This will be written as sigma of x square over n separately. Minus of 2 x bar is outside. Sigma of x over n plus sigma of x bar the whole square over n. This will be written as sigma of x square over n minus of 2x bar. Sigma of x over n, which is here, that will be equal to x bar. Let's replace this here with x bar plus x bar square is a constant which will come out from the sigma. This will be sigma of 1 over n. Sigma of 1, which will give you all the values of 1. You need to add it, which will be equal to x bar square and n value over n value. N will got cancelled from here because you have n values. If you do sum of all the values of 1, if you have n values, then answer will be n. N will got cancelled from here and you will get as sigma of x square over n minus of 2x bar square plus of x bar square, which is equals to sigma of x square over n minus of x bar square. If you subtract this, minus 2x bar square plus x bar square, you will get minus of x bar square. This shows you that this value is same as this value and standard deviation will be given by root of this value. When your mean is in decimal, then it's much easier to use this formula like 4.2, 5.7. What is the meaning of that? When you have the mean in decimals, this formula is much easier for you to use it. Let's understand this with one example here in both the ways. The mean of the numbers 2, 3, 5, 6, 8 is 4.8. Calculate the standard deviation. Here the mean is in decimal. So I have to use the second formula. But we will first see this example in both the ways, which way we will find it easier to solve it. In this case, mean x bar is given as 4.8 and the number n is given as 1, 2, 3, 4, 5. There are 5 elements inside it. So n is equal to 5. We will make a chart here. X values are 2, 3, 5, 6, 8. X minus x bar. X bar is 4.8. We need to see how much is deviated from the mean. Mean is 4.8. I need to subtract it 4.8 from the x. So if you subtract 2 minus 4.8, your answer is negative 2.8. 3 minus 4.8 is negative 1.8. 5 minus 4.8 is 0.2. 6 minus 4.8 is 1.2. 8 minus 4.8 is 3.2. I need to square this value here. If you square all these values, you will get the answer as 7.84. If you square this one, you will get 3.24. And you have to square this one, you will get 0.04. If you square 1.2, you will get 1.44. If you square 3.2, you will get 10.24. I need to add all the values, which will give me the answer as sigma of x minus 4.8 the whole square. If you add all of them, your answer is 22.8. If you put it in the standard deviation formula, which will be equal to root of sigma x minus x bar the whole square over n, this will be written as 22.8 divided by 5 because n value is 5, and I will get the answer as 2.14, correct up till 3 significant figures. We will see the same question with the second formula here. I have to calculate x square here. That means I need to square all the values of x. X are 2, 3, 5, 6, 8. If I square all the values, I will get 4, 9, 25, 36 and 64. I have to do the sigma of this value. Sigma means addition of all these values. If I add it, my answer is 138. If I use the second formula here, my standard deviation will be given as root of sigma x square over n minus x bar square. Sigma x square is 138. Divided by n is 5 because I have 5 terms inside it. Minus of x bar. X bar is given as 4.8. 4.8 the whole square. If you do the square of this one and subtract it from 138 over 5 and you take the root of that one, you will get the answer as 2.14, correct up till 3 significant figures. As we can see from here, this method is way easier than this method. So when your mean is in decimal, we are going to use the second formula, and if the mean is as a whole number, then we are going to use the first formula, then it will be more easier for us to solve it. Thank you so much for watching. I hope you enjoyed my video. Don't forget to like, subscribe and leave a comment down below. Bye-bye everyone.